Hello friends, today we are going to discuss another concept in the chapter Thermodynamics part first. So far we have discussed various concepts in the Thermodynamics first chapter, and another concept is work done in work done in irreversible process. Before we get started in detail, let us focus on what is work and what is irreversible process. Friends, in the previous few classes already we have discussed the concept of work, and in the types of processes we also discussed the irreversible process and reversible process. Let us focus on first the work, the concept of work. Students, we know to do any kind of work it requires some amount of energy. Without energy no system can perform work. So to carry out any kind of work, suppose if I ask you, suppose this is an object, and if I ask you to push the object to this place, then you have to do, you have to apply the force. You are applying force on this object to push the object from this place to this place, means you are transferring your energy in the form of force on this object to travel the distance of this much, whatever it may be the distance, to travel some distance. Okay, then only you can say work is done, whether on the system or by the system. Again, in short, to do work, energy is required. Without energy work is not possible. Okay, this is the work. And also we have discussed that work is the one of the ways of transfer of energy from system to surrounding or surrounding to system. That is, work is another form of energy. And mathematically this work is given as, mathematically work is equal to, we are applying the force on the object, that is force, and the distance, force into distance. Okay, the work mathematically is given as work is equal to force into distance. Now in brief, let us also discuss the another term in this sentence, in this title, that is irreversible process. Friends, we have discussed the reversible and irreversible process. Okay, suppose let us assume A is converting into B by a certain process. A is converted into B by some processes. This is the process. Whether this process is reversible or irreversible, how can one say? Depending on whether the process is irreversible or reversible, that can be predicted by knowing the driving force and opposing force. Driving force means the force which causes the reaction to proceed in forward direction, and the opposing force is the force which pushes the reaction to occur in backward direction. Okay, when the reaction, suppose this is the process, in this process the driving force, suppose driving force is far greater than opposing force, then what will happen? This reaction takes place only in one direction. The reaction cannot be reversed because the driving force is much greater than the opposing force. As compared to the driving force, the opposing force is very small, and that is negligible. That is why this reaction cannot be reversed. That is why such type of processes in which the driving force is much greater than the opposing force, such reactions or processes are called irreversible processes. These processes takes place only in one direction and probably in one step reaction. Okay, now I hope you understood the term work. It is nothing but the work is the one of the modes of transfer of energy from one body to another body or system to surrounding or surrounding to a system, means mode of exchange of energy. And irreversible process, the process which takes place only in one direction, that is in forward direction, because in such processes the opposing force is very small. That is why they proceeds only in one direction. Now we have to study what amount of work is done in these reversible processes. To understand this concept in detail, let us consider a gas is filled in a cylinder. Let us consider some gas is filled in this cylinder which is fitted with the weightless and frictionless piston. This is a piston which is having a very negligible weight, and it is having no friction along the walls of the cylinder. Means the friction between the wall of the cylinder and the piston is minimum, or there is no friction. Such a friction is fitted in this cylinder in which gas is filled. Okay, now gas has its internal pressure. When we say a gas is filled in the cylinder, means it exerts some pressure on the piston, and also piston experiences some opposing force in the form of external pressure. Okay, it is a gas pressure and it is the external or surroundings pressure on the piston. Okay, now if we consider the internal pressure of the gas is much greater than external pressure of the surrounding, then we can say that this piston will move in upward direction. Obviously, why? Because the pressure of the gas is much greater than the pressure of the surrounding, or which we call it as external pressure. And due to the great amount of pressure exerted by the gas will expand. Expand means the volume of the gas will change from V1 to V2. Obviously, V1 is the volume of the gas before expansion, and V2 is the volume of the gas after expansion against the external pressure or surroundings pressure. Now the piston is moved from this place to this place, and the distance traveled by this piston, let us assume it is a dl. Okay, the distance traveled by this piston from this place to this place, that distance is considered as dl, and V1 is the volume of the gas before expansion, and V2 is the volume of the gas after expansion. Now here we are considering the process is expansion. There are two types of processes, particularly in case of gases. Either gas may expand or the gas may compress. Expansion means increase in volume of the gas. Compression means if the external pressure is greater than the internal pressure, then this piston would have moved in the downward direction. Then the then we can say the gas is compressed in case of external pressure is greater than internal pressure. Okay, but here we are taking the expansion process. Gas is expanding against the external pressure of the surrounding. Now, just before we have discussed, work done is given as work is equal to force applied on the system multiply the distance traveled by the system, that is distance. Okay, distance. But friends, we know that force is nothing but, or we know that pressure is equal to what? Force upon area. The force applied per unit area is nothing but pressure. By this equation, the another form of this equation can also be written as force is equal to pressure into area. Pressure into area. Now we have the equation for work done. We have the value of force here. If we put the value of force in work equation, then we get work is equal to what it will become? Pressure. Instead of force, we have to put the value of force from this equation. Pressure into area into distance. Area into distance, or in the form of symbols we can write work is equal to pressure into area into the distance traveled by the piston. Okay, this is a dl. Okay, but again, however, area into the distance, the area into the distance is considered as change in volume. Therefore, work can be given as W is equal to what? Pressure into area into the distance is given as delta V. Therefore, work done during this irreversible expansion of the gas is given as W is equal to P into delta V, where delta V is nothing but, delta V means change in volume of the system during the process. Change in volume of the system during the process, which can be given as V2, how much amount of gas is expanded. Okay, the increase in volume of the gas during the expansion process is nothing but this much amount of volume is increased, and that can be given as V2 minus V1. V2 minus V1, or this equation can also be written as W is equal to, now this is the pressure of the surrounding, not the internal pressure, into delta V. Both equations are same, but the very small difference is when we use del V and delta V, when the volume, increased volume or decreased, change in volume of the system is very small, then we use this equation, and if that change is large, then we use this symbol delta V. This is all about the work done in irreversible process. Okay, I will repeat it again in brief as a summary. Now, we are discussing the work done in irreversible process. We know work cannot be done without providing energy to the system. Irreversible process which takes place only in one direction, because the opposing force of that process is very small as compared to the driving force. Therefore it occurs only in one step or in one direction. Okay, to understand this concept, we have assumed that, let us consider a gas is filled in a cylinder which is fitted with weightless and frictionless. The weight of, because it has to be very light in weight, then only we can get the accurate work by the expansion of the gas or system. Okay, the gas is filled in a cylinder which is fitted with the weightless and frictionless piston, and we have also considered the external pressure of the surrounding is much lesser than the internal pressure of the gas or the pressure of the internal gas. That is why this pressure is greater in amount. That is why it expands and pushes this piston up to this distance. During this expansion of the gas, since the external pressure is very low, the gas will expand, and the volume of the gas changes from V1 to V2, and during this expansion the piston is moved from this place to this place, and that distance traveled by the piston is given as dl. Okay, we know that mathematical form of work is given as work is equal to force applied on the system and the distance traveled by the system. Okay, the multiplication of force into distance gives rise to the work done during the expansion process. Okay, again we know that pressure is given as force applied per unit area, that is force upon area. This equation can be also written in the another form, that is force into pressure. This will come to left hand side and go into the multiplication pressure into area, or it can also be written as F is equal to P into area. Now put the value of this force in this equation, then we get work is equal to, instead of force we have to write pressure into area into distance. Okay, in symbolic form this equation can also be written as W is equal to P into area into dl, but area into dl is nothing but change in volume. Therefore W is given as P into delta V, or P, again this another form of this work done in irreversible process is P into delta V. But the most important thing in this, we are here the work, what is the type of process? Expansion. Okay, then this is nothing but, in the previous lecture we have discussed, when the gas expands means the work is done by the system or by the gas. Here gas is our system. The gas itself pushes the piston in upward direction, means gas is carrying out work on its own. Okay, or in simple words we can say work is done by the system, and when the work is done by the system it is always taken as negative, because it utilizes its own energy to push the piston in upward direction. It utilizes its own energy, means its energy decreases. Therefore the work during the expansion is always taken as minus W. Okay, therefore it can be also written as minus W, or this can also be given as minus W, or this equation can also be written as W is equal to, if we take this symbol minus on the right hand side, it will become minus P into delta V. This is the work done. This is the work done in, suppose if it is a positive, it is the work done in compression. If it is negative, it is the work done in expansion. Understood? During the expansion, work is always taken as negative, and during the compression of the gas, suppose external pressure is much greater than the internal pressure of the gas, then this piston would have been moved in the downward direction. Then we can say gas is compressed, volume decreased from initial volume. Therefore, during the compression, work is done on the system, and that work is given as positive work. This is the expansion and this is compression type of work. Okay, I hope you understood this one.